This lesson is not on 9.1, which is square roots. You may already be familiar with square roots, but in case you're not, let's review. The definition of a square root is of a number, n, is a number m such that m squared equals n. This is really somewhat complicated. Let me give you examples with numbers. So if I said 4, the square root of 4 is equal to 2, because 2 squared equals 4. So the square root is the inverse operation of squaring a number. So it's saying what times itself equals the number in this square root. And a perfect square is a number that is the square of an integer. So it comes out even. So the square root of 16 equals 4. However, if we do the square root of 15, it's not going to come out to be an integer. We can still do that, and we can use a calculator, which I'll show you later. But the square root of 15 would equal 3.87, and it's a decimal, so it keeps going. And a radical expression is an expression that involves a radical sign. So that's what we call this. So I may give you x plus 3 when x equals 16 and have you solve for it. So let's go through example 1 together. A community is building a playground on a square plot of land with an area of 625 square yards. What is the length of each side of the plot of land? Well, we know that the plot of a land is a square. That's important. So we know in a square that the sides are equal. So that this side is equal to this side. And we know to find the area of a square, it's the side squared, or side times side. So if that equals 625, then we can take the square root of both sides to get s by itself. So in this case, the square root of 625 is 25. So the length of each side of the plot of land is 25 yards. I hope that makes sense, and we'll do examples in class if it doesn't. And because they're no longer square yards, because we're not finding area, they're just plain yards. So example 2, what if we have a square root that doesn't come out to be even? So for example, the square root of 28. We don't have a calculator, but we want to estimate what it's equal to. So we know that a perfect square that is closest to 28 but less is 25, because 25, the square root of 25 equals 5. And the one that's closest to 28 but greater is 36, because the square root of 36 equals 6. So we can use our knowledge of this to say, we know 25 is less than 28, which is less than 36. So that means they're square roots. It's also true. And because we know the square root of 25 is 5 and the square root of 36 is 6, that means the square root of 28 is somewhere between 5 and 6. But because 28 is closer to 25 than it is to 36, we can do the difference. Then we know that the square root of 28 is closer to 5. So we can say it's approximately, so we use this squiggle equal, 5. That means it's close to, but it's not exactly 5. And if we were to do it in our calculator, we can see that the square root of 28 actually equals 5.29. So it is closest to the square root of 5. So I want you to try using your calculator to do this. So we're going to find the square root of 636. And the way you plug this into your calculator is first you press the second button. Make sure it's cleared. Press the second button. Then you should see a symbol that looks like this. Do not pick the one that has an X like this in front. This is no good. We don't need that at this point. We just want the plain square bar. Then plug in your 636, followed by a parentheses, and then equal, and you should get 25.21094043. However, we're going to round it to the nearest tenth, so 25.2. So what I'd like you to do is use a calculator to approximate the square root to the nearest tenth. I'm going to leave it like that. So try the square root of 6, negative the square root of 104, and the square root of 1,874 to practice using your calculator. And for our last example is, what if we have a radical expression, meaning not just a number under our square root. So if we had 5 times the square root of a squared minus b, when a equals 6 and b equals 27. The first step is let's substitute for a and b. So 5 times 6 squared minus 27. 6 squared is 36, minus 27 leaves us with 9. So 5 times the square root of 9, well 5 times the square root of 9 is 3, so 5 times 3, our answer would be 15. So I'd like you to do is try the following two problems when a equals 16 and b equals 9, and bring them with you tomorrow. That's all for this lesson.